So we're moving through operations with fractions, right? Same way you did when you were in elementary school. We learned how to reduce. We learned how to multiply. We learned how to divide. Now we're going to learn how to subtract. Let's talk about our procedure. What's the procedure for adding and subtracting fractions? In this case, they say rational expressions. Remember, that's just a fancy algebra fraction. What's the procedure? Common denominators, yes. You guys know that. Common denominators. And what we're going to be doing is I'm going to try to relate it to like what we did, like when you learned in elementary school, like what you learned in fifth grade. It's not that different than what you learned in fifth grade. It's just like some more fancy algebra goes along with it. So I want you to think of it like adding and subtracting fractions, getting common denominators. The work is split up in two different parts. The first part, and I teach this just like they do in elementary school. When you first learn how to add and subtract fractions, they have the common denominators for you already, right? That's going to be the same thing with this. We're going to start where it already has common denominators. So it could be something like this. And the first ones are super easy. It would have like, I don't know, 3x plus 1. And the denominator could be, it could be anything, like x plus 8. And then plus, and then I'll give you something else, like x minus 1. Whatever, I'm just making stuff up. And the denominator is the same. When you have common denominators, you just add the numerators, right? Everybody good with that here? Over here, don't write this. I'm just relating it to what we would have. It's like 4/7 plus 1/7, right? What's the answer to 4/7 plus 1/7? 5/7, right? You just kind of ignore the denominators and you add the numerators together. This is the same thing, but you got to add together the numerators. So the denominator is going to be x plus 8. Now I'm going to write this all out like this. 3x plus 1 plus x minus 1. You can think of it like this. Remember when we were solving equations where we would combine like terms? That's what we're going to be doing right here. We're going to be combining like terms. So we have 3x and x. How many x is that? 4x plus 1 and minus 1. 0. We don't need to write that. Over x plus 8. That's it. So the only difference here, why can't we, anyone know, why can't we cross out this x and x? The 4x can be separated. That's 4 times x. The x plus 8 is in parentheses, right? That is one number that cannot be separated. So you're not allowed to cancel those out. So that's it. Same thing with the 4 and the 8. That's it. It's as simple as it gets. Like, that's the simple answer right there. So again, let's compare that to what I had with and again, don't write this, but see, it's the same thing, right? The denominator is 7. The numerator, 4 plus 1 is 5. All we did is add some x's there. Everybody good with that? Yes. Well, there's 3 x's here, and there's 1 x there. How many total x's are there? 4x, and then the plus 1 and the minus 1 became 0. Well, it could have like 4x plus 7. I mean, like there could be something there. Okay, let's do a second example with this now. And now it is going to get, it's going to get more fancy. We're still going to have common denominators. It's going to look like this: 7x plus 5. And the denominator, 3x squared minus x minus 2. Don't worry about that denominator yet. Minus 4x plus 3. And it's going to have the same denominator, like all in the first half, same denominators. common denominators, right? We got to add and subtract or whatever the numerators. So I'm going to make one big line. 3x squared minus x minus 2 is the denominator because the denominators are already in common. Yeah? Okay. I'm going to write out the numerators and watch how I write out all of this stuff because that's going to be important. 7x plus 5 minus 4x plus 3. Let me show you the bad way to write this. And let's talk about the difference. The bad way to write it is like that. Tell me, guys, what's different between this and that? Yes. You have to distribute the negative. You have to distribute the negative. When students do this without it, and oftentimes it's those who don't show work and try to do stuff in their head, they'll often forget that negative goes to everything. So let's keep those negatives in. That's good. You guys all have someone in mind. All right. 7x plus 5 minus 4x minus 3. Because we just distributed. I can't say that. We just distributed it. There we go. Now, combine the terms. 7x minus 4x is 3x. 5 minus 3 is 2. I can tell you guys are having lots of fun. There's more to do with the problem, but wait, there's more. That's right. Very good. You got to simplify. Right? Imagine that we're adding and subtracting fractions, and we just got an answer that looked like that. You can't leave it that way. Well, remember, when you simplify rational expressions, they're fancy algebra stuff, you've got to factor. This numerator, 3x plus 2, cannot be factored, right? 3x plus 2. The denominator can. I'm going to do the cross products off to the side here. 3x and x. Let's see. Plus 2 minus 1. Yeah. Negative 3x plus 2x. Negative 1x. Yep. 3x plus 2. X minus 1. Now do you guys see something that can be canceled out? 3x plus 2, 3x plus 2. 1 over x minus 1. Done. Fine. Next. So those all had common denominators, right? Now we're going to have some where you've got to find the denominator yourself. Oh. Okay. Let's try it out. Here's our first example of that one. So now we need to make common denominators. Here's the example. 5 times 6x plus 3 times 2x squared. All right. We've got to think of the least common denominator. Now, when we think of the least common denominator, we can think of it, guys, with the numbers and the letters. So just think of this. Between 6 and 2, what's the least common denominator? 2. No. The least common denominator, like, no, not 12. It's just 6.
The least common.
Yes.
Divide.
It's like the least common multiple.
Oh.
6, right? So the common denominator here is going to be 6 because 2 times 3 makes 6, right? And this 6 times 1. Now, let's get the between x and x squared. What's the least common denominator? No, not. It's x squared. It's the same way. It's got to be like it's what does x and x squared both go into? They both go into x squared. right? Now, the common denominator is going to be 6x squared. So what you have to look at is for each denominator, what does this one need? It has 6x. It needs 6x squared. Well, how can we get another squared? Really, the common denominator is this: 6 times x times x. So what does this one need? Multiply it by x. Remember, when you do that, you do it to the numerator and the denominator. What about this one? What does it need? It needs times 3. And so now 5 times x, we write as 5x. 3 times 3, we write as 9. Here's the thing about this. If you get the least common denominator correct, you won't have to simplify it. Right? This is it. Watch. 5x plus 9, you can't factor. 6x squared, you can't factor it. That's it. Right? As long as you get the least common denominator, you're good to go. All right. Here's the last example that we're going to do. We're going to do 3x minus 1 minus 2 times x plus 2. Now remember this, x minus 1, I'm going to put in parentheses, that's just a number. Trying to think of what's the least common denominator here is kind of confusing, right? Like it's hard to tell. Let's think about this. Go back to being in elementary school, and if you couldn't figure out what the least common denominator is, you had a procedure, whether you realized it or not. Now, it's hard because like you're good at your multiplication tables now. But let me make an example. Don't write this down. What if I had this? 5 over 31 minus 2 53. What's the least common, or what's a common denominator between 51 and 31 and 53? Just multiply them together. Now, is it going to be the least? I don't know. But you know, if you multiply the two numbers together, you'll get a common denominator. You guys remember doing that, right? Like you just multiply them. So this one needs an x plus 2, and this needs an x plus 2. This one needs an x minus 1. It needs an x minus 1. Now, let me write out this whole thing. The denominator now is x plus 2 times x minus 1. That's just all those things, got a common denominator. And now we've got this, 3 times x plus 2 minus 2 times x minus 1. Let's talk about this line. We just multiplied the two together. We just multiplied it. Because the problem started like this. Started like that. So we just multiplied each of them. Okay, now let's talk about this line right here. Up here with these ones, we would just combine like terms. Think about solving linear equations, right? Do you guys remember what's the step before combining like terms? Distributing. Here, you're just going to distribute and then combine like terms. So we have 3x plus 6 minus 2x plus 2, right? Minus 2x plus 2. And then the denominator is the same. X plus 2, x minus 1. That's distributing. What comes after distributing? Combine like terms. 3x minus 2x is 1x. 6 plus 2 is 8. And that's it. You can't factor any of these anymore. That's going to be your answer. It's not that bad because if you get the least common denominator, you're not going to have to do any simplifying anyway. So your work's going to be in 2 parts. One part, it already has common denominators for you. You just add or subtract, and then you got to simplify. The second one, you've got to go through and make the common denominators.